to all. I am Dr. R.B. Benisha, Assistant Professor, Department of ECE, Rogini College of Engineering and Technology. In this video, we are going to see about the application development for the Internet of Things. In the application development of Internet of Things consists of the characteristics of IoT, application development challenges, related work, contribution, conclusion and ongoing and future works of the Internet of Things, and it consists of the challenges in the Internet of Things of application development. Next, we are going to see about the characteristics of things. In the characteristics of things, it may have consist of the sensor attached and it may have consist of the actuators attached. The sensor and actuators are the most important thing in the Internet of Things on the application development. It can communicate with other things. It can be involved in the information exchange between the physical and virtual worlds, that mean physical and virtual realities. Next, we are going to see about the marriage of sensor network and pervasive computing. The large scale is sensor network and the heterogeneity is pervasive computing. Consist of this both, the Internet of Things can be maintained. The sensor network and pervasive computing are the most important thing in the Internet of Things application development. Next, we are going to see about the multiple levels in the Internet of Things. It consists of three categories, that is, one is domain, another one is application and another one is deployment. The domain consists of smart environment, healthcare and transportation. The application consists of the HVAC and detecting fire. The deployment consists of INRIA Office and Google Office. These are the multiple levels of the Internet of Things. Based on these three categories, the Internet of Things can be classified or levelized. Next, we are going to see about the heterogeneity of the devices. In the heterogeneity of the devices in IoT, we have used different types of sensors and actuators. For example, temperature sensor, batch reader we are used. It has different implementation like Android and iOS. It has different interaction modes, that is PUB and sub, request and response and command interaction modes. It has used different data unit, for example C and F. But ideally, it should not be developed responsibility to handle the heterogeneity. Next, we have to see about the large scale of the Internet of Things. The large scale of the Internet of Things must be hundreds and thousands of devices equipped with sensor and actuators. The sensors and actuators are mostly considered as the large scale of the Internet of Things. The reasoning such a scale is not feasible or practical in the large scale method of Internet of Things in application development, but in need of adequate abstractions to present the large scale in suitable manner. Next, we are going to see about the separation of concepts. But in the Internet of Things, we have no separation of concepts. The Internet of Things application development can be classified into three concepts, that is, wide range of hardware and software entities running on specific platform or otherwise middleware specific feature and domain specific feature. But in the case of Internet of Things, all these concerns are largely coupled into the application logic. Need of separating all these concerns to enable the reusability. Next, we are going to see about lots of glue code. The stakeholders must have to write lots of glue code apart from an application logic. Firstly, we are interface the hardware and software components. Next, the interface of software components. Next, we have to see about the life cycle and future changes. The development, the application logic has to be analyzed and separated into a set of distributed tasks for the underlying network. The deployment consists of or defined as the task have to implement for the specific hardware. The evolution must be future changes in the infrastructure and application requirements of the IoT, but in case of covering all the application development in life cycle. Next, we have to see about the summary or the approach of the application development in Internet of Things. It can cover all the application stages, links of IoT development concepts, support modeling language and provide automation at all stages. Automation means it is consist of the robotics and their automations. Next, we have to see about the outlines. Normally, we have contains the characteristics of IoT, application development challenges, related work, the contribution of the IoT in application development, and conclusion and ongoing and future work about the IoT. Next, we have to see about the related work. The related work can be consist of three approaches. One is database, another one is library or toolkit based, and another one is model driven. The database based on the motivation of provide SQL like interface, address scale for data collecting application, offer abstraction to implement application, address heterogeneity partially. These are the approaches of the library or toolkit based related work. Then the another type is model driven. Raise the level of abstractions in program specification and transforms into working implementation. These are the motivation of the model driven. The examples for the database are TinyDB, Kyohar and SINA. The example for the library or toolkit based are GIA with Olympics and Context Toolkit. The example for the model driven approach is ATAG, Diasuit and PervML. The disadvantages of the related work: the database can be only for homogeneous devices, missing development lifecycle. The disadvantages of the library or toolkit based: lots of glue code, it has no separation of consents and missing development of lifecycle. The another disadvantages of the model driven is only cover a limited subset of requirements. These are the related work in the Internet of Things of application development. These three approaches are mainly considered at the related work. Next, we have to see about the contribution. The contribution of IoT must be consist of four steps. The first step is conceptual model, and the second step is development consents, and the third step is a set of modeling languages, and the fourth step is a multi-stage model-driven approach for IoT. The conceptual model can be captures the concepts and association to be present the IoT application. It can be given the classification of N concepts and development consents. The separation of consents and promotes reusability are specified in a set of modeling languages. Then they are combined in a multi-stage model-driven approach for the IoT. It is supports application development stages. And the set of modeling languages can be abstracts the heterogeneity, abstracts the large scale, and parameterized with domain. The development consents can be separation of consents and promote the reusability. These are the contribution of the Internet of Things in application development. Next, we have to see about the first conceptual model. Here we have to attach two conceptual model. The first conceptual model mainly consists of the software component. The software component can be extended from the users and stores and sensors and actuators. The user can be interacts with the end user application. Then the store can be provide access to the storage device. Then the sensors and actuators are extend the drive. The end user application can be extend the software component, and the storage device also extend the component, and the computational services and drives also extend the software component. It can be consumes or generate the information. It encapsulates system functionalities, provides traditional internet's concept, that is extends. This is the first IoT conceptual model. Next, we have to see about the second conceptual model. It may be mainly consist of the sensor and actuators and the software component. The sensors and actuators can be actuated by the sensors driver and actuator driver. They can be commanded or sensor measurement from the information. The software component can be consist of the user, storage and end user application and computational services and driver. The software components runs on the device, then the host sent to the resource are sent to the sensors, and the sensors observe the phenomenon, and the entity of interest can be consist of the phenomenon. The actuator must be affect the phenomenon. This the basic conceptual model of the IoT. Next, we have to see about the IoT application and its development concerns. The first one is the IoT application development concern is based on or classified into four types. The first one is domain, and the second one is application, and the third one is infrastructure, and the fourth one is deployment. The domain consists of the sensors and actuators and the source environment. storage environment. And the application can be consist of the computational services, end user application, and the deployment consists of mainly of the devices. The infrastructure consists of the sensors, drivers, actuators, and storage. It refers to underlying platform for a specific component. Next, we have to see about the vocabulary language. The vocabulary language is used for sensors and actuators. As a first step of abstracting heterogeneity, sensing and actuating entities are specified in high level manner. Here we have two classification, one resource description for many implementation and one resource description for many instance. Here we have used three models, that is struct, sensors, actuators, and generate. Next, we have to see about the second vocabulary language. It is otherwise called as SINA, that is defined as to address a scalable operation within an IoT system. Hierarchical clustering should be specified. It has consist of building, floor, and rooms. Used of region construct, the same model can be constructed. Enable system partition at logic level. Define scope from which software and component will produce or consume data. Next, we have to seen about the architectural language. The architectural language is mainly based on the scope of consuming data and scope of deployment. It is enable the hierarchical and clustering. Next, we have to see about the deployment language. The deployment language must be specified for the device name and the attached sensor or actuator or storage with the device. Here we have used the device name as a temperature sensing device and the sensors can be attached as bad scanner. Next, we have to see about the vocabulary specification. The vocabulary specification is the basic or the important step in the IoT application development. The first step is vocabulary specification. Vocabulary specification means and domain expert has been specify or refer the vocabulary specification. The vocabulary specification can be done by using a specific vocabulary language. The sensors, actuators, and storage are can be specified by using this vocabulary specification. Next, we have to see about the architectural specification. The architecture specification consists of the vocabulary specification also. The vocabulary specification means the domain expert has been refer or specify the vocabulary specification. Then the architecture specification and application designer can be specify or refer the architecture specification. He defines architecture of an application using a particular architecture language, here computational service and end user application. Next, we have to see about the implementing software component. In the implementing software component, it consists of 4 steps. The first step is the domain expert can be refer or specify the vocabulary specification. Then the system designer can be specify the architecture specification. Both the vocabulary specification and the architecture specification are combined in the framework, then generate the application framework. The application framework can be refer the application developer, then the application developer can be specify the application logic. In the implementing software component, it allows application developer to focus on the software component logic, that is application framework. Next, we have to see about the target deployment specification. The target deployment specification consists of 5 steps. The first step is the domain expert can be specify the vocabulary specification and the system designer can be specify the architecture specification. Both the vocabulary and architecture specification can be combined in the framework generator. The third step is the framework generator can be refers the application framework, then the application framework refer the application developer. The application developer can be specify the application logic. The fifth step is the target deployment specification, that means the network manager can be specify the network description. Here, in the target deployment specification, the network manager can specify the target deployment scenario using the deployment language. The deployment language mostly consists of the device. Next, we have to see about the mapping. The mapping consists of 6 steps. The first step is the domain expert can be refer the vocabulary specification and the application designer can be specify the architecture specification. Both are combined in the framework generator. Then the framework generator can be specify the application framework. The application framework can be refers the application developer. Then the application developer can be specify the application logic. The fifth step is the network manager can be specify the network description, and the mapping is consist of the architecture specification and network description. Both are combined and mapping, then it's refer or specify or outputting the mapping files. The mapping decided the specific device where each software component will be running. Next, we have to see about the writing device drivers. It consists of seven steps. The first step is the domain expert can be refer the vocabulary specification. Then the application designer can be specify the architecture specification. Both are combined in the framework generator, and the framework generator can be specify the application framework. Then the application framework can be refers the application developer. The application developer can be specify the application logic. In the fifth step, the network developer can be given the network description. Both the network description and the architecture specification can be combined and map. The mapping files are given to the device developer. Then the device developer specify the device driver. He writes device sensors device and network device and storage device. The next step is linking. The linking consists of 8 steps. The first step is the domain expert can be specify the vocabulary specification. The application designer can be specify the architecture specification. Both the vocabulary specification and architecture specification are combined in the framework generator. The framework generator can be specify the application framework. The application framework can be specify the application developer. The application developer can be specify the application logic. Both the application logic and application framework are combined and given to the system linker. The network description and the architecture specification can be mapped in the mapping, and using the mapping files, the system linker and the device driver are combined in the system link. Combine the generated code into a actual code to be deployed on the real devices. These about the linking. Next, we are going to see about the maintenance and evolution of the IoT in the application development. The adding new application in the existing infrastructure, moving an application from one deployment to another, implementing and plugging new device drivers. This is the main concept of the Internet of Things to be described by the user. By firstly we defining the domain consent, then the defining application can be consent, then defining the deployment, then defining the infrastructure, then we compile. If any changes in that particular compilation we want to change in this stage, this is known as maintenance and evolution. The second part is, firstly we want to change the vocabulary specification. If any change in the vocabulary specification we want to change in that particular situation. The next one is architecture specification. If any changes in the architecture design we want to change in the architecture specification. The third one is the network specification. If any changes in the network deployment or network files we want to change at the particular time. This is about the second maintenance and evolution of the Internet of Things in application development. Next, we have to see about the conclusion. It consists of the requirements and solved in our approach. The first requirement is abstracting the heterogeneity. In our approach, we are solving by using the vocabulary language, using the different types of resources, different types of implementation. The next one is architecture language. The another requirement is abstracting scale. It's solved in our approach by architecture and vocabulary language and scope construct. The separation of concepts consists of the conceptual model, capturing concept and association and classification of development concepts. The automation in development consists of the code generation and task mapping techniques. The covering application development stages can be solved by links development concepts, support automation in software development, combine modeling language, support for each stage of application development. Next, we have to see about the end user interaction with devices. The end user is going to play a major role in IoT application. It may be consist of three types. First is the originator. The originator is an user trigger an event or query to the application. The second one is the recipient. An user is notified a final result by the application. The intermediary is the user is prompt as required. But we will provide a particular abstraction to specify the user and interacts with the application. Next, we have to discuss about the mobility of the devices. The mobility of the devices is the current version of our modeling language consider only a static topology where the device do not move once they are deployed. But we will support the mobile devices in our future version by using variety of modeling languages. Next, we have to see about the evaluation of the expressiveness of modeling languages. It explores the subset of the IoT application characteristics that may have been suitably developed in the framework. Next, we have to see about what are the characteristics of IoT application that can be modeled by your approach. By our approach, it evaluates the time required to develop an application and to measure the development effort, and we plan to give our framework to our lab members with a suitable application. From this experiment, we will measure the total time to develop an application. This is the tentative timeline of the Internet of Things. In this tentative timetable is consists of the month, and we have to what to do that list. Firstly, February, we have to analyze the journal paper submission and finish the future work. This is given what will an intern do with the help of me. Next, we have to see about the intern will implement the different application using our framework. It outcomes and expressive of our approach, bugs identification and fix. Next, we will see about the intern will implement a wrapper between our framework and a middleware. It given a prototype implementation in real world. Next, the intern will write a documentation of our approach on web pages. The outcomes are it will guide the developers to develop the IoT application, and it will help our future PhD students to further and extend this works. Thank you.